Hi guys, this is a tutorial on perpendicular and parallel lines, which is 1H in your textbook. Just to start off with, we need to clarify a couple of words. First of all is perpendicular. So if you look at the perpendicular word perpendicular here, these two lines here are perpendicular. It just means that there's a right angle between them. Okay, so they're at right angles. Okay, the second thing is parallel. So parallel means two lines that never meet. Well, if they were, yeah, so parallel lines never meet. If they go off, these two lines are parallel. Okay, so you really have to nail those two definitions if you, they're kind of fundamental to this part of the section. Okay, so just the first thing, just with parallel lines, say if we had these two here and the gradient for this one was 2, for example, let's say 2.5. Okay, so by definition, the gradient is a measure of slope. So if you have a look at parallel lines, they have the same slope. So if you're given two parallel lines and you know one gradient, you automatically know the other. So the second one will also be 2.5. Okay, so that's one thing. It's quite simple with parallel lines. The gradient is the same. Okay, now perpendicular is a little bit trickier. So I'm going to attempt to have a look at this diagram that or this little applet I've created. I've got a line here. It's actually dynamic. I can change the line and it'll show you the rise over the run. So let's do something easy. Let's say, okay, so rise is 4 and run is 6. So working that rise over run, you're going to get 2/3. Okay, so that's just a line. It can be any line. Now, I'm going to put a perpendicular line in to that. Okay, so you notice that the black lines now, there's one that goes off at 90 degrees. Okay, so I've also put a little green, so the green dotted lines there indicate the gradient of that second line there, the perpendicular line. Okay, so you might notice something about the rise and the run. They've actually swapped over. So the run is now 4 and the rise is 6. Okay, so instead of 4/6, we're going to get 6/4. So what you can say about the well, we've flipped it. Okay, so it being a fraction, it flips over. The other thing you can also say is that this line here being positive, a perpendicular line to that will be negative. Okay, so let's just go back to our, what I might do is just stop for a second. Okay, so I've copied this over to my notebook. Now I'm going to use the red pen to work out the gradient of this, and we said it was 4/6. Okay, rise over run, which is going to be 2/3. Now, the way to tell if a second line is perpendicular is we say if it is the negative reciprocal of the first one. Okay, so what the reciprocal is basically the flipped form of a fraction. Okay, so a perpendicular line. Okay, so a perpendicular line has, has a gradient that is the negative reciprocal of the other. Okay, so for this one, okay, the reciprocal is going to be 6/4. It's just basically the flipped version of that one there, which is, we know, would be 3/2. Okay, so it happens to be negative as well, so you'd say that's negative 3/2. Alright, so if you had a line that had a gradient of 2/3, it's perpendicular. A line perpendicular to that will have a gradient of the negative of that, and you flip the fraction. Okay, so that works with whole numbers as well. I'll show you an example of a whole number. So if you said, let's say we had a line with a y equals 4x plus 3, and you asked, what? Okay, so you have this question or line here what gradient, if you had a line perpendicular to this line, what gradient would it have? Okay, so you start by writing down the gradient of this line, which we know is 4. Now, a perpendicular line will have the negative reciprocal of that, okay, which is a little bit tricky if you have a whole number, but as we know, we can write a whole number as 1 over 4. Okay, so the gradient of the perpendicular will be negative 1 over 4. Okay, now, I'm going to go on here and do some sample questions from the book. So let's have a look at these rules here. This is an example from the book. Decide if the graph of each pair of rules will be parallel, perpendicular, or neither. Okay, so it gives you a set of 2 lines, and it says, are they parallel, perpendicular, or neither? Okay, basically, if they're parallel, they have the same gradient. If it's perpendicular, one will be the negative reciprocal of the other. And if it's neither of those things, then the lines are neither parallel nor perpendicular. So let's have a look at the first pair. So y equals 1/2 x plus 2. Okay, we know that the gradient of this is going to be a half. Okay, now the tricky part of this one is not in y equals mx plus c format. Okay, so the number in front of x is not actually the gradient because this y is on its own. Okay, so what we're going to do is we're going to rearrange it so that it is. Okay, so the first thing you do is you've got to take a plus x to both sides. Okay, we're adding x, and you get x plus 5. Okay, now I simply divide everything by 2, and I get my y equals 1/2 x plus 5. Now, the gradient is a half. Okay, so you should be able to see that these, even though they don't look at it originally, when you put them in the right format, these are parallel. So you could say that these are parallel lines. Okay, because the gradient's the same. Now the second one there, sort of a bit all over the place here, but B, I'm going to do here. Let's look at the gradients for these 2 questions. Okay, and the second one is y equals 1/3 x plus 1. Okay, so gradient for this one is -3. The gradient for this one is 1/3. Okay, so you have to, they're not the same gradient. Okay, so they're not parallel, they might be perpendicular. All right, so is this, are these 2 things the negative reciprocal? Okay, so if I made that into a 3/1 and turned it, if I flipped it and I took away the negative, would I get that? And the answer is yes. Okay, negative 3/1 is the reciprocal of 1/3. So we actually say that these are perpendicular. Okay, now the last one there is probably the trickiest of the lot. Neither of these are in y equals x mx plus c form. So I'm going to go down here and we're going to work it out. Sorry, this is quite a long video. Let's work out these 2 here. So this is going to be c down here. So rewrite your equations, and x minus y equals 2. Okay, so what we're going to do here is get our x's on one side and our y on its own on the other. So let's take away 3x from both sides for that one. So that's 2y. Let's do negative 3x minus 5. Now I'm going to divide by 2, which gives me negative 3 over 2x minus 5 over 2. Okay, and finally this one here, this is going to be a matter of, what I'm going to do here is I'm going to take x from this side, take x, which gives me negative y, and negative x plus 2, and then I'm going to divide both sides by -1, which has the effect of changing all the signs, like that. Okay, so I've got two equations in the right form. M is negative 3 on 2, and over here our M is 1. Okay, now you have to look, do they have the same gradient? No, so they're not parallel. Do they have the negative reciprocal gradients, which means they're perpendicular? And the answer to that is no as well. So the reciprocal of 1 is 1. Sorry, 1/1 is 1, yep. And if you make that negative, it's not going to change anything. Okay, well, it's not going to make it this. Alright, so these are neither. We'll go back up to our original, and we'll write neither parallel or perpendicular. Okay, so that's how you do these questions. Bye for now.